Welcome to the ADF Insider Essentials channel for another relaxing swim in the application module pool. My name is Chris Muir, I'm a product manager for Oracle's development tools section. This is another video in the series to explore the application module pool in ADF Business Components. Are you ready for a swim in the deep end today? Today we're going to discuss some of the more advanced settings, so make sure you've got your floaties on. Alright, I'm all ready. So several episodes back we said that when discussing the application module pool parameters, some of the parameters deal with the size of the pool, but other parameters influence how the pool works, as well as the behaviour of the application modules themselves. As many watchers know, in web applications, typically you can tune for scalability or alternatively tune for user throughput, but you cannot necessarily have both. So let's investigate 4 parameters that, in changing how application modules work, impact the throughput and scalability of your applications, leaving you with a choice of which one you're going to tune for. The first parameter we'll discuss is JBO AM pool do AM pooling. But before investigating this parameter, let's take a quick recap on the concept of passivation and to describe some passivation problems developers may introduce into their applications, which will then explain the need for this parameter. As we remember, thanks to the JBO recycle threshold option, if we receive a new session request and all the application modules in the pool are referenced, a least recently used referenced application module will be passivated, so it can be reused by another session. If the JBO recycle threshold is tuned appropriately for throughput, where we want to avoid passivations altogether, passivations and activations hopefully should be a rare event. Ultimately, for user throughput, we want to keep all the active application modules in memory. Of course, if the system is under load, we have no available application modules in our pool, and our reference application modules has hit the recycle threshold, and in this case, passivation will occur. Now, it is possible during the active passivation and later upon activation that across multiple requests and responses for one user session, we may accidentally lose that precious application module state we keep on talking about over the previous episodes. So we'll discuss what can be lost in a moment, but as you can appreciate, this is extremely undesirable. Worse still, when losing state, this is one of those bugs that's extremely hard for developers to pin down. What will happen is occasionally users will say that they can see a bug where a value is not what they expected on the screen. But it only happens infrequently, say around 10 AM each Tuesday, when just by coincidence the system is at its busiest. Now remember, busiest equates to load, and if we've tuned our JBO recycle threshold correctly, only when the system is extremely busy will it start to passivate, where our possible passivation bug will start to be seen. In order for a developer to see that passivation bug, the AM their session is using must be passivated and activated across requests, which is where the possibility of the state being lost occurs. However, because of the LRU, the least recently used algorithm that chooses which application module to passivate when an available application module is required, the developer has no control over this. Their application module may never leave the pool nor suffer the bug introduced via passivation. This makes it extremely difficult to replicate. So what are some reasons for passivation bugs to creep into our application? One such reason is when developers create member variables in their overridden ADF-BC app module import and view object classes, or I should say view object import classes. ADF-BC does not automatically passivate member variables in these classes. So you need to override the parent class passivate state and activate state methods to ensure these values are read and written during the active passivation and activation. Another common mistake is in the view object attributes, that is transient attributes. By default, these transient attributes are marked not to be passivated to save space and time. Now, as you can possibly imagine, this is typically fine for transient attributes that are calculated from other persistent attributes because we can recalculate those values. However, if the transient attribute is one that the user enters themselves, a value that the user enters, across requests and responses, that value will be lost. So we need to mark that transient attribute as passivated. It's also worth mentioning the opposite problem to this, where developers choose to passivate every transient ViewObject attribute even when not necessarily. This causes extra work for ADF on passivating and activating, and obviously has a performance impact. There are further passivation bugs developers can introduce into their application, but what we've discussed here is probably the most common that Oracle staff have encountered previously. So now that you have a good understanding of what passivation entails, for the other bugs that you may encounter, you may accidentally introduce into your code, hopefully you'll have a better understanding of why these occur in the first place. Now, as these bugs can only typically be seen when the system is under load, when an application module is passivated and reactivated, and developers have no control over which AM is passivated, arguably it can be very hard to replicate the conditions to discover these bugs occurring. Is there anything in the framework that we can do to assist us in identifying these issues? The solution to this is the parameter jbo.ampool.doAmpooling. By default, this parameter is set to true, and it is responsible for invoking the whole application module pooling mechanism. Yet, if we set it to false, for all intents and purposes, there is no application module pool at runtime to persist application modules over requests. As such, what the application modules do in this case is they eagerly passivate to the passivation store upon finishing a response, and they eagerly reactivate state when a session returns from another request. Because we are eagerly passivating and eagerly activating over requests and responses, any passivation and activation bugs should come to the fore, and this should make the job for the developer of spotting these bugs much easier. Now, of course, as the system is eagerly passivating and eagerly activating on each request and response, all requests and responses for all sessions, the system will of course run much slower. But the advantages, of course, is we now have a mechanism to identify the passivation bugs we just previously discussed. In fact, Oracle recommends that for your application, you periodically run regression tests of your whole application with this option set to false. And developers should be encouraged to do this too in order to find those nasty little passivation bugs. The goal is to squeeze out those passivation bugs as early as possible during the development lifecycle, as well as educate developers to the mistakes they made in the first place. However, please note that Oracle does not support JBO doAmpooling set to false in a production environment. You must set this to true. Also, more generally, Oracle recommends you set it to true for user acceptance testing environments. As the goal in UAT is to ensure the system meets the user's requirements rather than necessarily hunting for bugs, in meeting the user's requirements, there is normally the implicit goal of the system being fast enough to respond while the user is using the system, i.e. the throughput is high. If you set this particular parameter to false in a UAT environment and the system is eagerly passivating and eagerly activating, there will be a performance hit and the user may end up indirectly commenting on that the system is too slow. So for UAT environments, this is another environment where you want to set doAmpooling to true, as well as in production where Oracle requires it in order for the system to be supported. Alrighty, that's our first parameter covered. Now, let's switch lanes. Okay, still got your floaties on? Let's switch lanes and talk about a separate parameter, JBO do failover. Now, I'll assume viewers will be familiar with the concept of failover in at least web applications, where if one node in our cluster dies, we want to switch users with no interruption of services to another node in our cluster. Imagine you've got a shopping cart type application. Surely you want those users to switch over to another node so that they continue shopping and buy items from us. Failover is normally a reasonable requirement. Now, admittedly, not all systems require failover, and to be honest, not all websites can be bothered with the hassle or expense of setting up a failover environment with multiple cluster nodes. But assuming you do have that requirement, what does the JBO.do failover option do to support failover? By setting JBO.do failover to true from its default value of false, what ADF Business Components does is it changes the behavior of the underlying application modules in the pool. Prior to now, application modules are only passivated when the system is under load, and we need to passivate out an application module to the persistent store to reuse the application module for another session. When JBO.do failover equals true, what the system now does is it will now eagerly passivate the application module state to the persistent store at the end of each request response cycle, though the referenced application module and its state will remain in the pool. The reason for doing this is, as nodes in the cluster share the same persistent store, typically a database, if an original node serving an original session request crashes, as the state of that application module and session are available in the database, in the PSTXN table for example, it's a fairly easy task of redirecting the returning session to a surviving node who can then activate the application module based on the state in the shared passivation store. As such, we see a side benefit of passivation is failover with the JBO.do failover option set to true. Now, to be clear, if JBO.do failover equals true and an application module is eagerly passivated to the database and remains in the application module pool as a referenced pinned AM to a session, on the next request for the session being received, it does not require activation as the referenced application module is still in the pool. However, if the system does hit load, just like previously as we described, it can also, that is the application module pool, it can also choose to completely offload an application module to the passivation store, then reuse the application module for another session's request, and reactivate the state when the original session returns. So the JBO.do failover equal true mechanism is complementary to the default passivation behavior. It doesn't override it. Of course, if the system is eagerly passivating with JBO.do failover equals true, there will be a performance hit. So you don't want to turn it on if you don't require failover. Separately, if you do need failover, while the passivation itself is desirable as this meets your failover needs, obviously the passivation performance hit is undesirable as it will hit your average user throughput. Yet in supporting failover, and therefore multiple nodes in your application server cluster, you are scaling horizontally. So it's assumed you will regain that loss as you're distributing load across nodes in the cluster. Alrighty, that concludes our look into the JBO.do failover parameter. Right, your floaties haven't gone down yet, you're still surviving, keeping with us in this deep end of the pool. So let's conclude this episode with the last two parameters which have to be talked about together. JBO.do connection pooling and JBO.txn or transaction.disconnect_level. Saying that enough times you get tongue twisted. These parameters are always talked about in conjunction with each other, though it's best to start with describing the behaviour of JBO.do connection pooling first. The JBO.doConnection pooling parameter, which takes the values of true and false, is unfortunately a poorly named parameter for historic reasons. It does not mean you are turning on or off the associated application module JDBC connection pool. Rather, the application module configuration editor label name for this parameter is much better: disconnect application module upon release. And an even better name would have been release the connection for the application module upon a check-in. What this parameter does when false, which is the default option, is influence how referenced or session affinity application modules hold on to their relating database connection from the connection pool. By default, to support better user throughput, a reference application module wants to be allocated and hold on to the same connection from the pool. As the act of fetching applications from the connection pool, potentially opening new database connections can have a performance hit. In turn, an application module that holds on to the same connection also receives benefits of prepared JDBC statements, database cache optimizations, and more. If a referenced application module checked into the pool is required to be passivated to be reused by another session, the associated database connection will be rolled back to clear any accidental or maybe incidental database connection state. And once the new session attaches to the application module impl prepare session method will be called to allow any database session logic to be set for the next session. As you can likely guess, pinning the connections to the application modules results in the potential for faster throughput for users. But the flip side is, while we have a number of idle referenced application modules in the application module pool with pinned database connections, those connections are possibly wasted, and taking out unnecessary connections for the database where they could be used by other applications and processes. If you instead change JBO.doConnection pooling to true, the application modules change their behaviour. Once an application module has finished its processing and is checked into the pool, the database connection associated with that application module will be released. Thus the name disconnect application module upon release. As you now have less pinned connections to these application modules, these reference AMs in the application module pool, this will increase the scalability of your application in terms of database connections, as your application will reuse a smaller set of database connections from the connection pool. Though, of course, the potential hit is it decreases your session average throughput. You'll note I say potentially because to take advantage of the things like prepared JDBC statements and the cache associated with that and the database caches, you need to have written an application that in turn makes use of those features. And that all depends on the characteristics of the systems you've built. Are you reusing SQL and the same data frequently? Databases and JDBC caches rely on applications doing very similar things to benefit from the cache in the first place. However, there is a downside of setting JBO.doConnection pooling to false. JBO.doConnection pooling set to false by itself, with no other parameters being changed, causes, here we go again, eager passivation and activation. And as we've discussed before, passivation and activation has a performance hit. So we seem to have introduced one parameter to solve one problem, but then just introduced another problem. Ideally, we don't want user sessions to get passivated or activated at all to increase the user session throughput. But unfortunately, if we want to achieve a more scalable system and capable of reusing database connections, it seems the hit when setting doConnection pool is we can't avoid the passivation and activation cycle. But remember I said we need to consider the JBO.doConnection pooling parameter alongside the JBO.txn.disconnect_level parameter. It's this second parameter that presents a further solution to the problem we just described. By default, the JBO transaction disconnect level parameter is set to 1, at least in JDeveloper 12.1.2. But when it was set to 0 in previous versions, and when doConnectionPolling equals false, this is when you saw the eager passivation and activation behavior. To avoid this, Oracle recommends setting JBO transaction disconnect level to 1, which it is now by default in JDeveloper 12.1.2 and onwards. What happens when it's set to 1? The passivation activations for doConnectionPolling will occur in memory without the I/O overhead problem that we were describing before of pushing them off to a passivation store. So, problem solved. Again, it's worth noting the normal under load passivation that occurs with JBO recycle threshold is not replaced. Application modules can still be passivated to the passivation store in this specific case. So the JBO transaction disconnect level parameter, when it's set to 1, the behavior is complementary to the default passivation behavior. It doesn't override it. One little caveat with the JBO TXN disconnect level parameter set to 1 is what happens if you require failover to be turned on. So JBO do failover equals to true. Do the two parameters conflict in this case? Because with failover you still require passivation. If you do have disconnect level set to 1 and do failover set to true, effectively that disconnect level parameter is just ignored, and the eager passivation that do failover requires still occurs. So ultimately the system will passivate to the persistent store in this case. Guess what? You've just been swimming in the deepest end of the application module pool, diving down as far as you can go. Swimming around, holding your breath, and now you return to the shallow end. If you've done all that and managed to keep your breath, well, you've now achieved something pretty fantastic. You've now learned most of the advanced concepts of the application module pool, and you're ready to go swimming every day in the pool, even the ocean. Well done. Extremely well done. You don't need these things anymore. So thanks for joining us on this ADF Insider Essentials episode today. We do appreciate your time. Hope you'll join us for another episode very, very soon. Cheerio.